So today in this class, we will be seeing about logical gates. So what are logical gates? Logic gates are the basic building blocks of any digital system. They work as a basic building block of any digital system. It is an electronic circuit having one or more than one input and only one output. So it may have more than one inputs, but the output is only one. Like you'll be having only one output. So the relation between the input and the output is based on the certain logic that we will be using. So based on this logic gates, they are named, like you'll be having AND gate, OR gate, NOT gate, and then you'll have NAND, NOR, etc. Okay. Now we will quickly look into the logic gates that we'll be having. So the types of logic gates. Logic gates. So we'll be dividing this into name. Then you will be having the symbol of the gate, the symbol, and then you will have truth table also over here. You will have truth table, and then you will have the Boolean form. I hope everyone know what is Boolean. Boolean formula. So let us just quickly start with the first one, that is AND. That this is an AND gate. So how will be the symbol of AND gate? You'll be having two circuits, X and Y. You'll be having two. One is X and one is Y. So as this is AND, this will come like this. Okay. And this is referred as F is equals to, actually this is the symbol of it, like you have to draw AND like this. And coming to the truth table, I hope everyone knows what is the truth table of AND, and this is the function. So how will we write the truth tables? Now here in logic gates, the truth value is denoted with 1 and the false value is denoted by 0. So what is the condition for AND? Whenever you have two truths, that is whenever you have two ones, then only the statement will be 1, rest of the elements will be 0. So before getting into that, we will just see this 1, 1, 1, 0, 0, 1, 0 and 0. So what is the truth table for AND? Whenever you have two truths, then only it will be true. The rest of the elements will be false. So this is what the logic gate of AND, like truth table of AND is. And what is a Boolean formula? What will be the Boolean formula for this? It will be F is equals to, as we are talking about AND, that is, you will have X dot Y. Okay, X into Y. Now coming to the second logic gate, that will be OR. So same thing, even this will be having two circuits, X, Y, and then this, as it is an OR table, this will be like this. Okay, so coming to the truth table, what is the condition of truth table? Whenever you have first we'll just write this 1, 1, 1, 0, 0, 1, 0 and 0. So what will be the function for this? If you have one true and one like if you have 1, 1, 1 will be 1, 1, 0 will be 1, 0, 1 will be 1, 0, 0 will be 0. Like if you have two false, what is AND? Or if you have two false, then the statement is false, otherwise it is true. So here you have two zeros. So here you have two zeros. So that is the reason you will be having 0. So what will be the Boolean formula for this? F is equals to, we are talking about OR. So this will be X plus Y. Okay. Next, we will be moving on to NOT. We studied about AND. We studied about OR. Now we will just look into, we will be looking into NOT. So the third one is NOT. So how will you define this? You will be having X and then NOT. Okay, this is x dash, and this is a plus circuit. So what will be the truth table for this? You'll have just two elements, that is x and f, that is 1 0 and 0 1. This is what the truth table of not is. And how will you define like what is the Boolean formula for this? F is equals to, as we are talking about x dash, this will be equals to x dash. Okay, now coming to the fourth one. The fourth one is an and. That is negation of and. I hope you remember all the definition of these connectives. So how will you, what is the symbol for this? You'll have x, and then you'll have y, and then you'll have a connection. As we are talking about and, this is what actually the and is. And there is n and, that is negation of and. So you'll have a circle, and then you'll have a circle. Okay, coming to the truth table of this. Coming to the truth table, what will that be? You'll have 1 1 1 0 0 1 0 0. So we are talking about n and. What is n and? Negation of and. So what is actually and? What is and? Whenever you have two truths, then you'll have true, otherwise it is false. So we are talking about the negation. So whenever you have two truths, it will be false. Rest of the statements will be true. Right? I hope you remember this definition. And the formula comes F is equals to, as we are talking about negation and, what is actually and is x and y, right? And negation is its whole dash. This is what the formula for n and is. In the same way, you can define n or. So what will be n or? N or's symbol will be, obviously you'll have x, y circuits, and then you will be having a connection. R is defined like this, and then you have to connect this, and we are talking about n or. So you'll have a circle, and then you'll have a plus. So what will be the truth table for this? X, y, and then you'll have f. Same thing, 1 1 1 0 0 1 0 0. So what is the truth table for this? It is negation of or. So what is or? Whenever you have two false, it is false, otherwise it is true. So whenever you have two false, that is if you have 0 0, you'll have 1, rest of the elements are zeros. Okay, now coming to the formula, f is equals to same thing, x plus y whole dash. Okay, in the same way you will be defining x or, that is exclusive or and exclusive nor. We'll just quickly define that, and then we'll see the circuits, how will we actually draw, that is the logic gates. Okay, next coming to x or. So what is x or? X is exclusive, exclusive or. So what is exclusive or? Same thing, you'll be having x and y circuits. You will be having, as we are talking about or, you'll have a connection over here. Now we are talking about exclusive. So there will be another circuit which connects the, I'll draw it a bit more clearly. You'll have x, then you'll have y, then you'll have a circuit, and then you'll have another one which actually connects. Okay, so this is what x or is, and the truth table is x, y, f. This is 1 1 1 0 0 1 and 0 0. So what is exclusive or? Identical truth values will be false. So this is 0, this is 0, and this is 1 1. How will you define? F is equals to x exclusively or into y. So how is this written as x dash y plus x y dash? Okay, this is what the Boolean formula for x or. Now coming to x and, sorry, x nor. That is negation of or. So this is exclusive exclusively NOR. So for this also you'll be having the same thing, that is X and this is Y. As we are talking about NOR, you'll have the same same connections. The only difference is you'll have a circle over here. Okay. So sorry, this is F. So X, Y, F. What is X or same thing? 1, 1, 1, 0, 0, 1, 0, 0. So here you'll have 1, 0, 0, 1. So what is the formula for this? It is F is equals to X, Y whole dash. So how will you write this? XY plus X dash, Y dash. Okay, you have to just, put negation for this. Now coming to how to design a logical gate actually for a given problem. So they told us to design a logical gate, design a logical gate, design a logical gate for Boolean expression or expansion, for Boolean expansion. So I hope you remember all the formulas. Expression. So the first one they gave as A plus B into A plus C dash. Okay. So as we are talking about and or, first what we'll do is we'll talk about, like, as we have an or. So first we'll just do the or circuit, like the logical gate. So what will that be? You'll have A, you'll have B, and as we are talking about or, how will be the or? Sorry, yeah. So how will you draw for or a connection? You'll have a circuit like this, and then this is A plus B, right? And in the same way, you got it for A plus C. So A is this and C is this. So you have to make a connection, and this will be A plus C dash. Let this be C dash. So A plus C dash. And they're asking an like, that is and. So you got to make a connection between these both. So how will you make a connection? Just draw it like this, and we are talking about and over here. So what will be the diagram, logic diagram for and? It is like this. Okay. So this will be A plus B into A plus C dash. Okay. This is what the logic diagram for A plus B into A plus C dash. Okay. Now we will move on to the next one. That is, I'll just do it here. The second one says A dash B plus AB dash. So before going with this, what is that we have to do is first we have to make A dash B and AB dash, and then we have to make an OR circuit. So how is that we'll be making A dash B plus AB dash. So first we will make A. What is A? They're asking A dash. So what is that you'll have? You'll have this symbol, and then you'll have a circuit. What is B? B is normal. So you'll have B like this, and there will be a connection. That is and. So how is and? And is like this. And is defined like this. And then you'll have another connection. Now we are talking about A and B dash. So A is normal and B will be, as we are talking about B dash. So that will be like this. Okay. And we are talking about and over here, like in the middle. So you'll have an and relation. Now we have to connect between these both. That is, you have to have or. So how will you define or? First bring these circuits together and then draw or. So how will you draw or generally? Like this. Sorry. So how will you draw or? Like this, right? So this is A dash B plus AB dash. I hope I'm clear with what is or and. Actually, what is and is defined like this. Whenever you have two circuits, and is defined like this. How you will define or will be defined like this. So whenever you have like dash and all, that dash will be defined like this. Okay. So we'll just move into one more problem, and then you'll have more clear idea. Here you have x, y, z circuits. Then you have x dash, y dash, z. Remember, whenever you have dash, you got to put this symbol like this, okay? And then x dash, y dash, z plus x dash, y, z plus x, y dash, z dash plus x, y, z. So first I will just write this x dash, y dash and z. So what is z? First x will be like this, and we are talking about dash. Sorry, x will be like this, and we are talking about its dash. So the circuit will be like this. So this is x dash, and I'm just leaving it here because we'll have an other relation. And what is y? Y is like this, and you'll have y dash over here. This is y dash, and then we'll talk z. Z is normal, so this will be like this. Now coming to, there is and relation between all these. So we'll just make a connection and write and, okay, and this goes like this. This is first one. And then coming to x dash, y, z. So what is x dash? X goes like this, and you'll have a x prime or x dash, okay, and then you have y is normal, so this you'll have a plane thing, and z is also normal, so you'll have a plane connection. And then there is and over here. So how will you draw and in the symbol wise? You'll have like this, and you'll have some connection. Next, coming to x, y dash, z dash. So x is normal, y dash, y is like this, and you'll have y dash over here, and then z, and then you'll have z dash over here, right? And then there is an and relation, so you'll have a connection. And then last one is x, y, z. So all the three circuits will be plain, x, y and z. That is logical gates will be plain. So, and there is an and connection between all these things. So put all these into one connection, and then this also, just make it together, and then this also comes like this. So now see, all these have OR connection. So just connect to all these things, all the four gates, and then put it together. Put this together. As you are talking about OR. So how will OR be? OR will be like this. 1 second. So OR will be like this, right? The symbol of OR. So you just have to connect over here. So just make a connection over here, and then you'll have a line. So all these gets connected. So what is this? F of x comma y comma z. So here you just have to write what are all these. So first one is x dash y dash z, and the second is x dash y z, and the third one is x y dash z dash, and the fourth one is x y z. Am I clear till here? Just make sure that you study and or symbol, and then the dash, like x dash or y dash. So how will you draw the x dash y dash thing? So you'll have a small triangle with a circuit. Okay. Let us see the other problem. You have a problem. They're just asking you minimization of Boolean expression, minimal sum of products. So now, without, like, if they ask you to use the logic gates, you have to do those, you have to make use of and, or, and then solve. Now what are they asking you is, they're asking you to minimize, yeah, so they're asking you to minimize boolean expression, minimize boolean expression, that is minimal sum of products, minimal sum of products. So how will you do, like, minimize this without the help of logic gates? We'll just see. So the first one, they just gave simplify f of x comma y is equals to x y dash plus xy plus x dash y. So you just have to simplify this. Now how to solve this one? Solution. Now consider the given, what is that they have given? Consider what is that they gave? F of x comma y is equals to xy dash plus xy plus x dash y. So you got to consider this. And now see, from these two, here you have xy plus x dash y, and here you have xy dash and xy. So from these first two elements you can take x common. If you take x common, what is that you have? Y dash plus y, and plus the third term will be as it is, that is x dash y. And you already know y dash plus y is equals to 1 from Boolean properties. So this is equals to x into 1 and plus x dash y. Okay. So what is that you have here? X plus x dash y. And this I am just writing it as x plus x dash into x plus y. So this actually I wrote it from, like, whenever you have a plus b dot c, you can write this as a plus b dot a plus c, right, from the distributive property. So I'm just writing it as like in the same way, x plus x dash into x plus y. Okay. So you know x and x plus x, like if y plus y dash is equals to 1, obviously x plus x dash also will be equals to 1. So this is 1 into x plus y. So what is the answer that you got? You got x plus y. So when you simplify f of x, that is this whole term, the remaining answer that you'll get is x plus y, that is in terms of x comma, like function in terms of x comma y. Now note that there is a note point. Note. So what are they telling is, like, f of 1 comma 1, whenever you have f of 1 comma 1, that is x value is true and y value is true, this is equals to, like from previous example, xy dash plus xy plus x dash y. So now if x is 1, y will also be 1, x dash will be equals to 0, y dash will be equals to 0. So this is 0 plus x into 1, y will be 1, this is also equals to 0. So f of 1 comma 1 equals to 1. Okay. So this is equals to x plus y. Am I clear? Now simplification by laws of algebra, Boolean algebra, and simplification by, okay. So simplifying are actually, or simplifying, you can either do it by Boolean algebra, or you can do it by Karnaugh map. So till now we have done with Boolean algebra, and then we saw how will we solve the logical gates using it. And now we will be seeing Karnaugh map. Karnaugh map will be seeing in the next class.